Good day, everyone. This is Gifted Brain, and today we shall be studying Logarithm 1. Under this study, we shall be considering 1. Introduction to Logarithm, and 2. Laws of Logarithm with several examples.
So the logarithm of a number p to base b is a number x to which b must be raised to be equal to p. What this simply means is, for instance, let's say I want to know the index x10 must possess, 10 must have to give 1000. You know, all I simply need to do is to just take log of 1000 to base 10. Whatever it gives to me, that is what that x is. Actually, it is going to give us 3. That's my x. So if I do 10 raised to power 3 now, I will get 1000. Let's say at another instance now, we want to say what must 2 be raised to, or what is the index 2 should have, so that it gives us 5, for instance. To get this, all we just need to do is to say log of 5, log 5 to base 2. Whatever it's going to give to us now, it is what that x, it is the index 2 should have to give 5. So this is actually going to be 2.321928. I actually got this using my calculator. So, but that is what the x is here. So for my definition, I'm looking for the index of b that gives me p. If I don't know, all I need to do is to say log p to base b. Whatever it gives to me, which is the x, that's why we said logarithm of a number p to base b is the index x to which b must be raised to be equal to p. That is the definition of logarithm. This logarithm is governed by certain or several laws, and then we'll be considering laws of logarithm. So we're looking at the first law now. Say log p base b plus log q base b is equal to log p multiplied by q to base b. Before this first law of logarithm can be applied, let's say we have two different log of numbers. Their base must be the same. As we can see in this law now, each of the two log p and log q, has the same base b. So the base must be the same before we can apply this first law. It therefore means that if I say, for instance, log 2 plus log 3, as long as they have common base, let's say they have base 5 and base 5, what I will simply do is to say this is log 2 multiplied by 3 to base 5. And that's what this law is about. So that's log 6 base 5. Let's take some examples now. Example 1. So it says simplify log 9 base 4 plus log 3 base 4. Because they're having common base now, I can apply the first law of logarithm. So this will simply be log, I'm simply going to say 9 times 3, and that's 27, and to base 4. So that's that about that. Let's take the second law now. So the second law says log p to base b minus log q to base b is equal to log p divided by q to base b. So let's consider this example 2 now. Log 27 to base 2 minus log 9 to base 2. Obviously, this is going to simply give us log, we have 27 to base 2 minus log 9 to base 2. This will simply be log 27 divided by 9, then to base 2. And that will give us log 3 to base 2. So that's simply the second law. Let's take the third law now. The third law says log 1 to any base is 0. Not necessarily a particular base, whatever base it is, as long as the number is 1. And that's why you see log 10, log 1 to base 10 is the same thing log 1 to base 50. Same thing as log 1 to base 5. As long as the number is 1, the answer is simply 0. That's what this third law is saying. As long as you're taking log of 1 to whatever base it is, the answer is simply 0. So the fourth law now. The fourth law is that log of a number to the base of that same number is 1. What this is saying is that, you see, if I say log 10 to base 10, or log 6 to base 6, it would have been log 50 now to base 50. As long as the number and the base is the same, the answer is simply 1. The answer is simply 1. That's the fourth law of logarithm. Let's take the fifth law now. Fifth law of logarithm. Please, the example 7 here is a mistake. It ought to be example 3, but I just left it like that. We have that log p raised to power n to base a is equal to n multiplied by log p to base a. What this is simply saying is this, that whatever power a number has, that power could come to multiply the log of that number. What I'm simply trying to say is this. You see, if we say log 50 raised to power n, for instance, to whatever base it is, this n as a power of the number could come to multiply the log. It simply would become n multiplied by log of 50 to base b. So that's what this law is simply saying. So we have some examples here. Evaluate the following: log 100 to base 10. With that first one, actually, very simple. So we all know that 100 itself is 10 raised to power 2. So this becomes log of 10 raised to power 2 now to base 10. And then the 2 could come to multiply log 10 to base 10. And we know that log 10 to base 10 from our previous law is equal to 1. When the log of a number has the base of that same number, it is equal to 1. So this is 2 times 1, which is 2, because log 10 base 10 is actually equal to 1. So that's that about that. Let's take the second one now. Quite an easy one. We have log 16 to base 2. So obviously, because this is base 2 now, I'm going to look for how to transform 16 to 2 to the index of something. And so, that is 2 raised to power 4 actually. So this is log 2 raised to power 4 base 2. And then the 4 could come behind and multiply log of 2 to base 2 now. And that will give us 4 times 1, which is equal to 4. So we take the next one now. And so we have half of log 343 base 7. I know that 343 can become 7 raised to power 3. So that becomes an easy one to do. So we would have 7 log 7 raised to power 3 now with our half behind. So that will become 3 multiplied by 1 over 2, which multiplies log 7 to base 7 now. Log 7 to base 7. So that will be 3 times 1 over 2
times 1, because log 7 base 7 is 1, and that'll give us 3 over 2. So finally, we're taking the last one now. And so the next now we just need to check here is to see how to transform this. Now we have log 2 over log 9 over 4 to base 2 over 3. First of all, I could turn this to log 3 over 2 squared to 2 over 3. There's a similarity now. We all know that 3 over 2 can become 2 over 3 raised to power minus 1. So this can be log 2 over 3 to minus 1. And then there's a minus 2. There's a 2 there before as a power. So it multiplies that. So we have 2 over 3. This is because I know that 3 over 2, this is because 3 over 2 is same as 2 over 3 raised to power minus 1. So because of that, that's what made us do what we do. So we now have log 2 over 3, base of 2 over 3 to 2 over 3 raised to power minus 2 now. So minus 2 can come behind to become minus 2 log 2 over 3 base 2 over 3. And that will give us minus 2 times 1, which is minus 2. So that's about that. So the sixth law says that log p to base a raised to power n is equal to 1 over n log p to base a. What this law is simply saying is that when the base is raised to a particular power, that we can take 1 over that same power, multiply by the log of that same number to that base, but not having the power any longer. And what this law is simply saying that, let's take an example now. Let's say we have log 5 to base 2 raised to power 3. Simply, I can say this is 1 over 3, 1 over power of the base now, multiplying the log of that same number, but the base not having the power again. That's what we're trying to say. So let's take some examples under this now. Okay, so the first question we have is log 32 to base 4. Obviously, 32 cannot be 4 raised to power anything that is whole. But we all know that log 32 as a number can be 2 raised to power something. But the unfortunate thing here is that my base is not, the base of this logarithm is not 2. So what do we do? Can we change the base to become 2? Obviously, yes. So you see that first of all, my base, which is 4, can become 2 raised to power 2. And then my 32 now can become 2 raised to power 5. Easily now, I can take back the power of the base to be 1 over 2, and the power of this number back behind to be multiplied by 5. Then we'll now be left with log 5. Sorry, log 2 now, not 5. Log 2 base 2. And this will simply be 5 over 2. Very easy one now. For the second one, we have that log 2 to base 4. Well, very, very easy. Here, my base is 4. And because my base is 4, I'm looking for a way to transform that base to have the same number of the logarithm. So what I will simply do is to say that my base should be 2 raised to power 2 to the number 2. And so the power of the base can come behind as 1 over 2 now, multiplying the log 2 to base 2 now, log 2 to base 2. And that will be 1 over 2 multiplied by 1, which is 1 over 2. So quite an easy one. And for the last one now, we have, okay, so log 125 to base 0.2, sorry. So this can be written as log, and we know that 0.2 in fraction can be 1 over 5. And then we will have the 125 now. And that again, that 1 over 5 can be written as 5 raised to power minus 1.
And then 125 can be written as 5 raised to power 3. And so we would have the minus 1 coming behind, minus 1 over 1, which is exactly minus 1. And so, or 1 over minus 1, which is exactly minus 1. So there's no need. I will write it as, or let me write it as the way it should be. 1 over minus 1, then multiplied by 3, then multiplied by log 5 base 5. And this will just be equal to minus 1 times 3, which is minus 3. So that's that about that. So seventh law of logarithm. This is called the change of base law. This law is simply saying that log p to base a divided by log q to base a is equal to log p to base q. You can see that the result we obtain is a new base, which is the base q. And the initial logarithm we have, we're in base a. And so you see that the base has changed. And so we can use this law to change base when necessary. But I want to say again that people often confuse this law with the second law. The second law is simply saying that log p base a minus, this is not divide now. Two logarithms are subtracting log q base a. And then we just simply have to divide their numbers. Only their number is dividing. P divided by q to the same base. The base remains the same. Unlike these two separate logarithms, not one single logarithm, and their numbers are dividing. Here, two separate logarithms are dividing. So don't confuse these two laws. And we can see how we can apply this to some examples. We can see that even the examples we did in our previous example 6, we can apply this law to solve such a problem. Let's look at some examples now. So the example 1 says log 32 to base 4. The problem here is that 4 cannot be expressed to have an index which can give 32, meaning that 32 cannot be equal to 4 raised to power a whole number. And so what do? We see that the ground here is that 2, base 2 is, because 2 can be expressed to a power to give 4, and 32 can be expressed as 2 raised to power something, also a whole number. So because of that, now we're going to use base 2. That's what we're going to use here, because there's a link between 4, 32 to giving us 2 raised to power something. So this will give me log 32 to base 2 now divided by log 4 now to base same base 2. And with this now, we can now say this is equal to log 2 raised to power 5. That's what 32 is, base 2, divided by log 2 raised to power 2 still to base 2. And we can now say this is equal to 5 log 2 base 2 divided by 2 log 2 base 2. And then obviously this will give us 5, because log 2 base 2 is 1 times 1 all over 2 multiplied by log 2 base 2, which is still 1. So my answer is just 5 over 2. And that's why we apply this same answer we got when we solve this question using the sixth law actually. So let's look at the next example. So look at this second example now. We can still say that we see a uniform number here we can use is 3, because 27 can be expressed as 3 raised to power something, while 9 as well can be expressed as 3 raised to power something. And these numbers, these indices are whole numbers. And so because of that, I can say this is log 3 or log 27 to base 3 divided by log 9 raised to power minus 1 base 3 likewise. And then we can say this is equal to log, the 27 now can be 3 raised to power 3 to base 3 divided by log 9 is 3 raised to power 2, and then there's a minus 1 power also, then base 3 likewise. This will be 3 log 3 base 3 divided by log 3 raised to power minus 2, because 2 times minus 1, then base 3. So this will be 3 times 1 all over minus 2 times, obviously, log 3 base 3 is still 1. So my answer is just minus 3 over 2. So that's that about that. So we'll consider further examples on logarithm now.